this is Mrs. Hall. I just wanted to go over and review about multiplying and dividing exponents and also evaluating equations. So I'm going to do a problem and then I want you to try one, and then I'm going to do one and then I want you to try one. So you have to make sure you watch through this whole video. This will be part of your assignment for the day. And I'm sure an assignment will be listed somewhere within this video as well. So let's look at number 1. Number 1, it says multiply a to the 3rd power times a to the 8th power. To do that, that equals, you keep the base, so the base is going to be a, so you keep your base, and then you add the exponent, so 3 plus 8, and what is 3 plus 8? 11. So a to the 3rd power times a to the 8th power equals a to the 11th power. So on a sheet of paper, I want you to try this one. Alright, number 2, we have c to the 6th power divided by c to the 2nd power. When you divide, you keep your base is c, so you will keep your base, and then you subtract the top minus the bottom, so it would be 6 minus 2. And what is 6 minus 2? 4. So c to the 6th power divided by c to the 2nd power is equal c to the 4th power. This will be the second problem you should do on your paper. You are to do y to the 3rd power divided by y to the 2nd power. Number 3, if I say you have g to the 9th power divided by g to the 12th power, this one's going to be a little bit different. I would look at this one as, well, let's do it the subtraction way first. You have g to the 9, so top minus bottom. Do not do the bigger number minus the smaller number. It is top minus bottom. Okay? And 9 minus 12 is negative 4. Okay? But you do not want to have negative exponents. You only want to have positive exponents. So when you have a negative exponent, the way I've always thought about it is change signs. So to change it from a negative to a positive, you have to change sides. So you'll take that and this will flip to the bottom, so it'll change to the bottom. It's like almost like a reciprocal. So you have g to a positive 4 power and you hold this with a 1. Another way you can think of it, if you have 1, 2, 3, 4, 5, 6, 7, 8, 9 over 12, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can cancel, cancel, cancel. I'm sorry. 9 minus 12 is negative 3, not 4. I don't know why I was so confused. Okay, so you have 3 g's left on the bottom. everything on the top is completely wiped out, but you can always multiply all of these g's by 1. That would be the imaginary coefficient. So you would have 1 with 3 g's on the bottom, and g times g times g is the same thing as 1 over g cubed. So either way, you still get the same answer. Okay? Now I want you to try one. This is number 3 in your papers. I want you to take y to the 3rd power divided by y to the 7th power. And I want you to give me that question. Alrighty, for number 4, you have ab squared c times 2a squared b c squared. So first and foremost, there would be an imaginary coefficient of 1 in front of this a here. So now we do numbers first. So what's 1 times 2? 2. A times a squared. This is an imaginary exponent of 1. So 1 plus 2 is 3. So a to the 3rd power. B squared times b. This has an imaginary exponent of 1. So 2 plus 1 is also 3. And then has an imaginary exponent of 1. So c to the 1st power times c squared. So 1 plus 2 is 3. So c cubed. Okay? I want you to try one now. I want you to do x squared y z times 3 x y to the 4th z to the 6th. Okay? Alright, number 5. Number 5, you have something similar to, let's say, 24a to the 4th b over 8a squared b cubed. So first and foremost, let's do the numbers. 24 divided by 8 is 3. I'm going to create my fraction bar underneath it just in case we have anything left on the bottom. So now we're going to look at a to the 4th divided by a squared. So 4 minus 2 is 2. The bigger number's up top, so the extras are going to stay up top. So I have 2 left on top, and in this case I have 1b down here, 3 b's down here. 1 will cancel, so I have 2 b's left on the bottom, which is b squared. So my final answer is just 3a squared over b squared. Alright, I want you to try one, and it's going to look similar to sorry, I don't know what happened. Alright, so that over and this will be your number 5. Alright, for number 6, we have 2c x cubed times 3c squared x times 4, I guess, cx. So don't forget you have an imaginary exponent of 1, an imaginary exponent of 1, imaginary exponents of 1 on those as well. So it does not have an exponent. At least it's not visible. It does have one, it's just a 1. Okay? So now let's first do the numbers. So 2 times 3 is 6, and 6 times 4 is 24. Then we're going to do our c's, so we're going to keep our base c and add the exponent. So 1 plus 2 is 3, plus 1 more is 4. And now we're going to do the x. 3 plus 1 is 4, plus 1 more is 5. So you'll have 24 c to the 4th power, x to the 5th power. So now I want you to do one. I want you to do 3by squared times 4b squared y times 2by. Number 7, I have 9x to the 4th power over 3xy. So don't forget you have an imaginary exponent of 1 on the x and the y. Let's do the numbers first. Can you do 9 divided by 3? Yes, you can. It is a whole number 3, so the 3 will go on top. This is like I'm saying I have 4 x's here, and I have 1 down here, so this will cancel 1. I have 3 x's left, so I have x cubed, because I have 3 left. Don't forget, to the power of 3, you can also say it's cubed. And then I don't have any y's on top, so my y is just going to have to stay on the bottom. We can't cancel it with anything, so we can't simplify it, so it's just going to stay where it's at. Return number 7. Number 8. Now we're just going to go back to, for review and solve. So we have, let's say I've got 4x is equal to 8. If I want to solve for x, I have to do opposite operations. So if 4 is being multiplied by x, the opposite of multiplying by x is dividing. So I'm going to divide both sides. I want to get x by itself, so I want to get rid of this 4. So I'm going to divide by 4 so they cancel out. And what you do to one side of the equal sign, you must do to the other. I'm going to draw a little line down my equal sign, so I did it once to the left, once to the right. I have x left over on my left hand side, and 8 divided by 4, don't forget this is also division, 8 divided by 4 is 2. So x equals 2. For number 8, I want you to try x is equal to 35. Alright, number 9, I have x plus 4 is equal to 7 times 3. Well, first and foremost, I'm going to simplify this right side here. What is 7 times 3? 7 times 3 is 21. My equal sign will always stay on the line in the middle. Alright, so now I want to get x by itself, which means I want to bring this 4 to this side. So I'm currently adding 4. The opposite of adding is subtracting, so I'm going to subtract 4 from both sides. Plus 4 and minus 4 will cancel, which gives me just x left over on the left hand side, which is great because that's my goal, is to get x by itself. And 21 minus 4 is 15. I lied. 17. I don't know where I got 15 from, I'm sorry. So I want you to give number 10 a shot. I want you to do x plus 7 is equal to 2 times 9. And number 10, I have 4a minus 10 is equal to 14. I'm going to draw a line down my equal sign. I want to get a by itself. The 4 is connected to the a. We're going to save that for last. We're going to do the minus 10 first. So, to get rid of a minus 10, the opposite of subtracting is adding. So we will add 10 to both sides. This will cancel our 10s there, which gives me 4a is equal to 14 plus 10, and 14 plus 10 is 28. And our goal is to get a by itself. A is still not by itself yet. And if you have a number in front of a letter, don't forget that means multiplication, and there's a little invisible multiplication sign in between. So 4 is being multiplied by a. The opposite of multiplying is dividing. And again, we want to get a by itself, so we have to get rid of this 4. So we're going to divide by 4. Our 4's will cancel. A is equal to 28 divided by 4, which is 7. So a equals 7 is our final answer. A is by itself, so we're done. Alright, so I want you to do 8a minus 40 is equal to 28. Alright, next, number 11. We're going to simplify. (4x plus 9x). So the 4 and the 9 are called coefficients. When you combine like terms mean they have the same variable to the same exponent, which is a 1. We have like terms, we can add the coefficients and keep the variables and the exponents the exact same way. So first we're going to do 4 plus 9, which is 13. Then we keep our variable and we keep our exponents the same. If our exponent is a 1, it is not needed, so we can just say 13x. So for number 11, I want you to do 3x plus 6x. And I want you to simplify that. For number 12, write the number of terms in a monomial. So don't forget, monomial has the prefix mono. It is singular. There will be one term. Now I want you to tell me how many terms are in a trinomial. number 13. If I said you had 6a to the 9th power, what is the numerical coefficient? It's the number before the letter, and the letter is called the variable. So it's the number before the variable. My variable is right here. It's the only letter in my equation, or in my, it's not even an equation, in my expression. 6 is the number before my variable, so my numerical coefficient is going to be 6. For number 13, I want you to tell me the numerical coefficient of 4x to the 5th power. What is the numerical coefficient? Number 14. Write A, B, using exponents. Alright, so exponents are the numbers that are the small numbers that are superscripted on your variable, so it's the little numbers up top. So I have how many a's? 2 a's, so I have a to the 2nd power because I have 2 a's. And how many b's? I have 2 b's, so it's also b to the 2nd power. I want you to write this using exponents. C, 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 E, G, G. I'm actually going to go ahead and pause here. We will continue later on. Make sure you complete 1 through 14 for the blue problems that say try. Make sure you send a picture of those in by Friday.